Everyone. In this part of the video, I want to show you how we can connect the lines between the vertices to complete the outside of our yield sign. To begin, I recommend splitting these equations over circles into two, where we have the positive half and the negative half. And this will make it easier to define inequalities on how far each of the circles should go, and also if we do need calculus to calculate how the tangent line connects, we could use that to our advantage. So split these. We need to solve for y on the other side. So to do that, let's copy this equation, subtract this whole x term over, take the square root of both sides. I'm just going to cut this. Right, SQRT, that gets you the square root. And you put this inside. And you can add this term to the other side. There's our positive solution. For the negative solution, just tack a minus sign to the front. Do the same process for this one here. Subtract the x term. Take the square root of both sides. And you add this value to the side. Duplicate it, make this negative. We have both halves. This one, I'm already inclined to believe that you really just need a negative solution. But let's do both so that we don't prematurely delete something that we end up actually needing. Actually quite simple. Y is square root of r sub 0 squared minus x squared minus r1. Duplicate this. And let's make this negative. Now that we have the two, let's connect the top line. So we know where the center is. We know the distance to the top, and therefore we can compute what the y location of the line should be. Let's make a comment for edges. We know at the center is going to be this value here. So y should be this. We need to calculate the radius, that is r0. And this line is made of the y component of the distance from the center to this point here. And to calculate the distance, we need the x component. And so we can grab that from here. This is negative because this is really x minus the negative of this. Less than or equal to the positive version of that. And that allows us to edit this circle to be everything to the left of this line. And then for this top line here, you can click on it directly and it'll tell you which line it is. So we'll say we want everything to the right of this. Alright, now I'm going to show you how you can connect these two vertices together. First off, I'm going to hide the lines that we're not interested in. So that would be the edges and also this vertex that we're not working with yet. We have a few smaller goals in mind. First off, let's find a point that goes around all points on the circle. To do that, we need the radius of the circle. That is R0. So let's make some temporary variables here. Let's call this one A1 is R sub 0 times cosine. We need an angle. And this angle will become relevant to us, but not yet. Is the x component and a y component r sub 0 sine of d sub 1. And when we plot this, we need to move this over to where the center of this circle is. That is this point here for the x. And for the y, that is this value here. So now if we slide this degree around, you can see how this point just rides that circle very cleanly. Right, next we need to find a line that's tangent to this. But before we can find a tangent line, we should find the line that goes the other way. It goes from the center to this point here. So let's call this one. Let's put the slope down here. M1 start with this point, B sub 1, that's first y. And it doesn't matter which point you use first as long as you're consistent. So B1 minus the center. So the center of this is this value here. A sub 1 minus. You can use the same value, just know that this is the x component and therefore should be sine. So you have the slope. And we should be able to solve y equals m sub 1 x plus b. We need to find out what b is. To do that, we can just sub this point is so much easier to work with than trying to use these other points here. And so let's sub in these values. That is b sub 1 minus m sub 1 times a sub 1. B sub 1 minus m sub 1 times a sub 1. And we'll just substitute this value back in. We need the inverse of this. So I'm just going to cut this, write 1 over. In fact, it should be negative 1 over that. So now if you slide this d around, turns out there was a bit of a mistake in my math. The signs for the y component, which is why you want to pair with the y component up here, and the cosine pairs with the x component. So now if you slide this around, you can see that this line is tangent with this. Now in terms of which angle to pick for this one, we know that from this line up to this point, from earlier, we calculated this to be 30 degrees, which should be pi over 6. Which means if we made this pi over 6, well, negative pi over 6, this line should hit perfectly with this line here, well, the bottom half. So I am inclined to believe that we can safely delete this line. We should keep this. And this goes up to, alright, this is going to get really interesting. Since we're moving variables upwards now. So we'll call this tangent angles. And this line here should be x is greater than or equal to a sub 1. I like having variables defined before we use them. Even though it seems like Desmos is okay if we don't do that. And for this line, we would say x is less than or equal to a sub 1. I want to complete the rest of the edges off camera, and then we'll reconvene. I've completed the graph, well, just the edges. And some tips: if you've computed one of the values here, like this line for example, as long as it's centered along the on the x-axis, you can just take the negative of that and it'll get you the other value. And so that was what I did for the rest of the graph. If you have questions on how the rest of the puts computed, do let me know, and I'll probably make a follow-up video on that. Other than that, let me know if you have any questions, and hope you found this video helpful, and I'll see you next video. See ya.